All right, today we are going to continue studying other types of equations. Today we're going to solve equations that are quadratic in form or involve absolute value. So the first ones we're going to talk about are quadratic in form. So we just got studying quadratics. Remember, those are polynomials of degree 2. Today we're going to study ones that don't quite look like it, but will end up being solved very similarly. So the first thing we're going to do is we're going to use substitution. So we're going to replace something using substitution to make it look more familiar to us. After we do that, we're going to solve it just like we have been, with factoring, square roots, etc. Once we solve like it's a quadratic, we resubstitute the original value and find out what the actual solution is. In step 4, of course, you're welcome to check your solutions. So we're going to solve each equation by making the appropriate substitution. So we're going to start with these, which I consider to be a little bit easier than the ones we'll see on the next page. In example 1, we have x to the 4th minus 8x squared minus 9 is 0. So taking a look at this trinomial, it's set to 0. Normally we would feel comfortable factoring. The reason that we don't is because we have this 4th power here and a 2nd power in the middle. So when this is happening, we're going to do what I call U substitution, where you let U equal this middle term right here. So that's going to be U is equal to x squared. So the middle term right here. Because now when I talk about x to the 4th, that's really x squared squared, correct? So I'll write that on the side. X to the 4th is really x squared squared. Or in other words, as we said over here, if x squared is u, that's really u squared. So I can replace x to the 4th with u squared minus 8, and I can replace x squared with u minus 9 equal to 0. Now you'll see that we have a quadratic trinomial. That's something you're more comfortable solving. So I'm going to go ahead and factor that. So I'm not going to take too much time talking about that. What multiplies to -9 and adds to -8. We get u minus 9 and we get u plus 1. I would set those to 0. U minus 9 equals 0 and u minus 1, or excuse me, u plus 1 equals 0. So I'd get u equals 9 and u equals -1. But we're not done because now we have to go back and actually substitute what u was. U was x squared. So here, x squared is 9, which means that x is plus or minus 3. Here, u is -1, which I substitute again. X squared is -1. And remember, the square root of -1, we're going to get plus or minus I. So our solutions to this are plus or minus 3 and plus or minus I. All right, let's take a look at example 2 now. Same idea here, x to the 4th minus 5x squared plus 6. Now in this problem, we happen to have a similar thing going on here, where I don't like this because it's a 4th power, so let's do some substitution. That middle term yet again is an x squared. So I am going to again let u be x squared, which means I have u squared minus 5u plus 6 equal to 0. Factoring, that becomes u minus 2 and u minus 3 equal to 0. Setting those factors to 0, u minus 2 and u minus 3, I get u is 2 and u is 3. But remember, in the beginning, did I even want u? No, I wanted x. So I have to resubstitute my x values in place of my u's. So that's x squared is 2 and x squared is 3, which means I get x to be plus or minus root 2, and I get x to be plus or minus root 3. So plus or minus root 2 comma, plus or minus root 3. Those are my solutions. Now if we move on to the next set, they look a little bit more complicated. I've got rational exponents. 5x to the 2/3 plus 11x to the 1/3 plus 2. All right, for this one, we're going to have to take a little bit more time, just being careful. So, in the last two problems, u was equal to x squared. In this problem, my u is equal to the middle term, which is x to the 1/3. So I'm going to let u be x to the 1/3 here. So I get 5u squared plus 11u plus 2 is 0. Remember, it works out to be u squared because x to the 1/3 squared is x to the 2/3. When we factor this, you can use the box, but what it turns out to be is 5u plus 1 and u plus 2 equal to 0. So I set 5u plus 1 equal to 0 and u plus 2 equal to 0, and I solve. So u is equal to negative 1/5 and I get u is equal to negative 2. But remember, I don't want u, I want x, so I resubstitute. X to the 1/3 is negative 1/5 and x to the 1/3 is negative 2. Now to solve for x, remember, you have to raise it to the reciprocal power. So we're going to raise this to the third power, and I get x is negative 1 over 125. Over here I raise it to the third power. Negative 2 to the third is negative 8. So my two solutions in this problem are negative 1 1/25 and negative 8. All right, I want you guys to try example 4 and come in with the solution in our next class. We're going to talk about that to start. So let's write that down. 3x to the 2/3 minus 11x to the 1/3 minus 4 is 0. I expect to see some effort here. You coming and saying, oh, I didn't know how to do it is not okay. You need to try something out here. All right, the last thing we're going to talk about today is solving absolute value equations, and there's 4 steps to that process. First, you have to isolate the absolute value term. So you have to get whatever's in bars by itself. Once you get that, it's really easy. You rewrite it as 2 separate equations without the absolute value sign. Okay, one of them is going to be equal to a positive number, the other will be equal to a negative number. You solve those equations, and boom, you can check them to make sure that they're right. All right, so we're going to do 2 of these real quick. Solve it or indicate it that it has no solution, and sometimes that does happen. So step 1, we've got 5 absolute value of 1 minus 4x minus 15 is 0. Step 1, we have to isolate. And remember, we're still solving, so we're still doing SADMAP here. So with SADMAP, who can I subtract or add over to help us to start this one? The 15. So I have 5 absolute value of 1 minus 4x is equal to 15. Now who can I divide or multiply by? That 5 in front. Divide both sides by 5, so the 5's go away, and I have the absolute value of 1 minus 4x is equal to 3. Now the absolute values bars are by itself, so what we do is we drop the bars, and we're going to set it equal to positive 3 in one equation and negative 3 in another. So 1 minus 4x equals 3, and 1 minus 4x equals negative 3. And you solve, so you subtract your 1, divide by negative 4, and we get x is negative 1/2 here. Over here we subtract our 1 to get negative 4, divide by negative 4, and we get x is positive 1. They are both good solutions. You could check those out if you would like on your own. Now on the next problem, let's see what's different about it. It looks pretty similar. Who can I subtract or add over? I've got 4 absolute value of 1 minus 2x minus 20 is 0, so I'll add that 20 over. 4 absolute value of 1 minus 2x is equal to 20. Who can I divide or multiply by? That 4. And I get the absolute value of 1 minus 2x is equal to 5. Now that the absolute value is isolated, we drop the bars and we set it equal to positive 5 and to negative 5. Subtract my 1 and divide by negative 2. Same idea over here. I subtract my 1 and I divide by negative 2. And I get my two answers, which are negative 2 and 3. Now I'm going to pause here for one last thought. In this slide we had talked about what happens, how would we get no solution? It all comes down to when we get to this last step here before we split. What do you know about absolute value? Absolute value should always be equal to a positive number. We had it equal to a positive 3 and a positive 5. If either of those numbers were negative, once we isolate it, that's after we get everything away through SADMAP, and we get the bars by itself. If this was equal to a negative 3, the answer would have been no solution, because the absolute value cannot be equal to a negative. All right, please come ready with your questions to class, and I look forward to seeing you.